very much. And this is about the hackathon last month. And the topic about the hackathon is about real time. We use you can use WebSocket or Socket.io or whatever framework you want to build some real-time applications. And for our team, actually, this is not my project. It is our project. SK is one of my member, and Connie is coming. I think she is OT somewhere. Yeah, and she's coming anyway. And let me show you what's. Let me see. Yeah, a teammate, SK, Connie, and me, Edward. And the source code is available on GitHub. And the game is actually running because we use Meteor, and it provides a free service for us to host our games there. So you can go there and play our game. But remember to change the ID because it is the player identity. We just simply change the ID there. Yeah. Otherwise, everyone is player one. Pokemon. Yeah, and yeah, actually the rundown of hackathon is a 3-day. On Friday, we brainstorm and form team formation. And we have a lot of ideas, but we work for our favorite project as we form the team together. And then we go home and sleep or do some research. And then on Saturday morning, I think 10 a.m., we go back to Eddie's office in Mongkok, and we start our coding. And then I think in between we share our progress with other team, and also the difficulty we faced. So sometimes Eddie and his team share their ideas and their experience with us. And on Sunday we program games, and then we do a short presentation. I think you can find the presentation on Facebook. Yeah. And what we did actually, and in the very beginning, we want to build a real-time strategy game, just like Warcraft and AOE, yeah, something like this. Yeah, but actually, it's very difficult because we have to synchronize the clients, and we have to decide who is the master, and what's the data shared between each client, and build the UIs, and it is very difficult actually if you don't use any framework or any rendering engine. And also we have to do some. We have to use the physics engine because there are some collision detection and the object's movement. We have to simulate all this kind of physics, and also we have to make sure the game experience is good because I think the minimum acceptable frame per second is 30 for normal computer games you play with. But actually, if you convert this FPS to second, it is about 33 milliseconds. It is actually the round trip time because whenever you click the button on your computer, it has to send to the server and then send back to the other clients. This travel time is around 33 milliseconds if you want to maintain this kind of this high FPS. Yeah, so it's very difficult. So we kind of give up, and because it's too much for this hackathon. So and suddenly, I think of a game. We played these games in my friend's home for I think 2 years ago maybe, and maybe I'll show you the gameplay videos first.
Okay, there's 2 seats down at the front if those guys want to come in and.
Oh, sorry, some technical problems.
B, work around B.
Actually, this game is called Choo Choo Rocket, and this is by Seeker. Maybe it's very slow.
Yeah, take some time.
Okay. This is a gameplay. Maybe I skip the intro. Okay. So there is some some mice here, and there's 4 players. Each player has to have their own destination. You have to put some arrow here to guide the mice. Also the cats to the destination. For example, this blue player is player 1. He can place 3 arrows in 4 directions: up, down, left, right, and to guide this little mouse to his own base. But if the cat go to the base of this player, for example, this green player, his score will be dropped by half, I guess. And this is the spawning point. So the mice will spawn here. I think it's set. It has some direction. So each mouse is, for example, move in this way. And so it's like this. And each player can only place 3 arrows. Just like this. Yeah, and this game is good for our project because it's very simple. Yeah, very simple because each player has only one action: place the arrow. Yeah, and yeah, let me continue. Yeah, we just seamlessly copy this game. Yeah, and the game logic is computed on the server because all the mice spawning and the collision detection is on the server, and yeah, and the movement, the map you can see that is a grid base, and no fancy collision detection is needed because if 2 objects are on the same grid, they are collide and maybe destroy each other or get some score. Yeah. And the map design is quite minimal. We just have for our game, we just have have wall around this map and no other wall inside this grid. Yeah, and yeah, this is actually our game's UI. Yeah, maybe I just show you the games. Yeah, it's here. It's running, and I am player 2. And maybe Eddie can go to this game. You.
You play first.
Yeah, I'm
take some time.
I'm player 2 already. Yeah. Let me. Yeah. And yeah, maybe SK help. Yeah, and I can use WASD on the keyboard to place the arrow. For example, I place key W here, and it will send a API call to the server, and the server will place an arrow here. Eddie, I'm coming.
Oh, is it?
WASD. Yeah. Is that okay?
Wait.
So we have some technical issues.
What keyboard are you using?
This thing, I think.
Oh, there's a bug.
Okay.
Oh, okay.
Oh, yeah. Are you using Firefox?
Firefox.
Oh, Firefox. We only design for.
Oh, okay.
I don't know why. Yeah, maybe. Yeah, and yeah, this blue point is the mice, and yeah, this is the destination. You can think this is the file going to the cloud server somehow. Something like this. We just use the icon from Bootstrap, yeah, to display, and yeah.
Yeah, I'm changing. Yeah.
Oh yeah,
The red arrow.
This is Eddie, and yeah. So I can put the arrow here to redirect the mice to Eddie's base, and I can also redirect the cat. Oops.
Yeah, all the free stuff.
Oh, maybe the
Yeah,
network
okay.
problem. Sometimes there's a problem because if your connection with the server is very bad, then the game will pause. Yeah. Somehow it will resume. Somehow, I don't know why. I don't know how. Yeah. Somehow.
Real time.
Yeah, real time. Yeah. And at the very beginning, we have to choose between Meteor or using something IO. At the end, we choose Meteor because SK know how to use Meteor, and I have no experience in Meteor or Socket.io, so we choose Meteor, and yeah, and it is very kind of easy to use, and yeah, I think it is. I think it prefers convention over configuration because when you use Meteor, if you want to add some library you have to put the file into the right directory. Otherwise, the server cannot load the JavaScript or CSS, HTML to the client, and then you can read the find menu on Meteor, and there are lots of built-in package bundled with Meteor. And for example, underscore, bootstrap, and less. And yeah, and actually, the magic behind Meteor is that it has server-side MongoDB and server-side MongoDB. And each time, if you can use some MongoDB command in your browser. For example, some connection.insert. It will I think it will send some API call to the server, and the server will handle this kind of database update, and then send back send the data, synchronize the data with other clients. Yeah. And it provides some publish and subscribe style programming, and also it provides free server, so you can host your game or your application on meteor.com. Yeah. Of course, you can use Meteor's command line to create your own bundle to deploy the program on your own server. And yeah, some basic workflow for Meteor. First of all, you have to define the connection, actually the database, yeah, and then define some HTML campaign and the data for the campaign. Actually, this data should be from the database, and then you just provide some way to update the data in the server or the client side. For example, you just for our case, actually the client side have no function to update to direct access the database. It has some API call to the server, and the server will process this and do some database insert to the on the server side. Yeah, and we have some game objects, for example, the cat, the mice, and etc. And there are two game loops here. We have a spawning loop. For example, each 10 milliseconds we spawn some mice, and then another loop is update the mice position and the cat position, and do other things such as collision detection. For example, if the mice is collide with the cat, and it will destroy the mice. And other thing will just change the player scores. And actually the game is quite simple. I will show you the code. Here it is on SK's GitHub. Can you see that? Yeah. And yeah, this is the main JavaScript file. Yeah, equal total. It's just 366 lines. It is not very optimized. We just because it's a hackathon, no one cares about documentation. We just put all the constant here. The naming is not good. You can see a lot of high code here. Yeah. So at the very beginning, you define the collection. Define the collection, and there's some constant here. And yeah, we have some helper function to, for example, to move the mouse. This is this syntax. If you use MongoDB before, this is the operator. Yeah, we just return this to update the mice or the cat. Yeah. Yeah, and this is a helper function. And this part is the way you get data for the campaign engine to update the client size. Then this is the API call from the to handle the API call from the client. Whether the player can paste the arrow, because when player one pastes the arrow in one grid, the other player cannot override it. And yeah, and then this is the server size thing. Just you can see that the game loop. Here, we just do from the database we get all the mice and then do some collision detection and update the movement, update the position and then the cast and update the score. Yeah, just 366 times here. And I'm sorry. And you don't have to tell the client to pull or to update because Meteor do the magic things for you. You just have to insert to the database or just update the records in the database, and then Meteor will do the job for you. And then otherwise you can you can still use Meteor's publish and subscribe method to do your own update operation. And the UI, you can see that there is no fancy CSS and JavaScript there. And the server for this stage update loop, we use I think the loop is we run the loop every second. Yeah, this is you can because in the very beginning I said that the high FPS is very difficult to achieve. So because the game is very simple, we can use a very long game loop. And because so for every second the server will send the objects position objects to the client, and in that 1 second time frame, all the mice will survive alive. And we just use a CSS animation to show the movement of the mice. And after that second, the game will run again and calculate whether the mice was eaten by the cat or it reached the destination. And lesson learned. Meteor is very good and easy to use, but you have to follow the convention first. Because at the very beginning, I don't know the convention, and I just add the JavaScript there, HTML there, and it doesn't work. It spent me a lot of time to read the document, and also the tutorial on the on Google is now maybe not updated because the Meteor framework is still under development, so the tutorial may not work. So you have to be very careful about the answer on Stack Overflow and then on the Google. And also you have to consider the network delay, and because it's not on the LAN, so you have to, because this kind of network delay will affect your gameplay seriously. So I think for the real-time strategy games, you cannot use implement it on over the internet, but maybe you can look for the Bomberman online. There is a Bomberman online games on the internet. You can Google it. I think the project is open source a few years ago. I don't know if it's closed source now, but it allows thousands of people play on the same game room. I don't know how they can do it, but maybe you can look. And perhaps Socket Out is more suitable for production because, to me, synchronizing to the database across different clients is too bulky to me. Just my opinion. I didn't do any research about this, but I think this is too bulky. The game is just like MVP, but this is not not the crappy version of my ideas. Just test our idea and learn the difficulties. There's a lot of I don't know. There's the network delay is so serious in the game. Before I do the games you have to use Bootstrap and Nest because they save you a lot of time. If you go to the GitHub and see my CSS, it's very ugly. A lot of code there. And the framework change too fast. You please be careful about the tutorial. And that's all.
Thanks. Any question for Edward? Like all the
Sorry,
stuff.
I just want to interrupt everybody. If anyone wants to use the toilet,
Yeah.
it was great, Edward. On the door, there's like a key here.
Okay.
You just have to basically pull it out. Just use the bathroom on the right-hand side, the other side, and if you would put it back, we would really appreciate it. Also, welcome to the workground, and we are 13 offices here for mutual coders and business people, startups, and dreamers of all ages. We've got a form rotating around. Please leave your email address. And, if you like us on Facebook and take a photo and add it, we'll give you day passes so you can come check out. And thank you for coming.
Thanks. Thank you. Okay, sorry. Get back to Q&A section. Yeah. Any question for this project?
So just to clarify, you said the sync database that it's Meteor that has the sync database or something else?
I think for media you have to because for our games the server control all the data, so you have to synchronize the data between all the kinds. I think each kind won't have any peer-to-peer connection. But I think if you use WebRTC or somehow you use WebRTC for your game, you can create some peer-to-peer connection. Maybe the games is much faster to you. Because the media, I don't know where is the videos, where is the server of the media. You can't control. I don't know how. Maybe you can hack the video. You can check the source code. I don't know how they update the records, but to me, I want to control everything. So I will use socket data.
You said you were greatly affected by lag, and you're running a Meteor server in the cloud somewhere. Is it because, like, it's probably in the States, probably, so...
Yeah.
Like, are you, like, syncing all the way to the States?
Yes. Yes.
That's probably why.
Yeah, maybe.
Which cloud service?
I don't know because I don't have the server's IP or information.
Did you testing whether or not if you open persistent database connection versus just opening it every time that actually set it up? Or like say by chance if we like create a game, either trade, you can keep all the data in memory and update the
Actually, after the hackathon, I come back home. I try to somehow optimize the game loop. Yeah, I don't have any data, but I just want to optimize it somehow. So I try to put all the database updates to the end of the loop, and put all the data in memory and do all the calculation in memory. But the performance seems not as good as I think, because the data update is too bulky, and the MongoDB is somehow asynchronous. So if you put all the data updates at the end of the game loop, so you cannot use the how to say when you put data in the database, because it's asynchronous, you can use that time. When the database is working, you can use that time to compute other stuff. But if you put the update at the end of the loop,
Yeah.
Okay.